Although spider silk in general has useful bioinspirational properties, its strength and elasticity varies depending on species. For this reason, we modeled our design off of the species with the strongest and most elastic silk in order to make our product perform at its best. Spider silk has been known to biologists and engineers as a material for bioinspiration in many different fields. Some current designs using spider silk include soundproof metamaterial, single-walled carbo nanotubes, and certain kinds of clothing.
Using AutoCAD Fusion 360, we defined a custom material to represent silk produced by the yellow garden spider, given values of the Young's modulus, shear modulus, Poisson's ratio, and tensile strength from Koski et al. We applied the material to a model charging cable with a fixed end where the connector would be plugged into a device and an applied load of 100 newtons in the direction of gravity, simulating a user tugging on the cord. From the simulations, we found that the maximum stress experienced by the spider silk insulating material was 308.1 megapascals as opposed to 481.5 megapascals for a low-density polyethylene, which is an industry standard for charging cord insulating material given its durability and insulating properties. Spider silk's greatest advantage is its ability to resist fatigue and tear over several load cycles, unlike most other materials, as outlined by Kumar and Singh in their paper titled Fatigueless Response of Spider Draglines in Cyclic Torsion Facilitated by Reversible Molecular Deformation. The maximum stress as observed by the AutoCAD simulation occurs directly near the interface between the wire insulation and a support structure, which is where tearing began in the example cord here.
From Ko et al.'s paper, Engineering Properties of Spider Silk, we found out that spider silk's stress-strain behavior compared to other materials such as Kevlar 29 and Nylon 6 was the closest to ideal because it provides the best balance of strength and toughness. Additionally, when the spider silk's compressibility was tested, results showed that the spider silk had the lowest ability to resist transverse compression compared to the other textiles, indicating a high level of anisotropy.
Spider silk is extremely fine. Its diameter ranges from 0.5 to 10 microns depending on the species. However, it must be strong and flexible in order to capture any flying prey that lands on the web. Our design will use the silk's capability of withstanding impact in order to create wires that are more flexible and durable than wires used today. By embedding spider silk into insulating materials such as silicon dioxide, we can create wires that can last longer. Spider silk is also a natural protein-based polymer, thus our design will be more eco-friendly by producing less toxic compounds for electrical wires.
Spider silk exhibits a plethora of advantages over the current polymers used for wire coating. As a natural insulator, spider silk can be modified with hydrophobic polymers to substitute the plastic or rubber used today. The material is tough, resilient, and most importantly biodegradable. With the advancements of technology, there has been a consequential growth in electronic waste. Usually the discarded devices are stripped of its metals and the remaining plastic is burned in communities around the world, releasing toxic chemicals into the atmosphere. It has been estimated that the volume of electronic waste is growing 3 to 5% per year. Therefore, it is imperative for companies to be mindful of their products' environmental repercussions in order to reduce the anthropogenic pollution. Ideally, wire coatings used in electronics, hospitals, industrial settings, and even international internet cables can be replaced by their spider silk-inspired polymer. To achieve our goal, we would collaborate with a variety of engineers and wire manufacturers. The silk can be sourced from the Craig Biocraft laboratories, where scientists have successfully genetically modified silkworms to mass-produce spider silk instead. Furthermore, there has been a burgeoning of literature displaying spider silk as a conductive material when modified with gold particles or carbon nanotubes. Although normally an insulating material, spider silk now will be capable of effectively conducting electricity and ultimately replace the metal inside the wires as well. The future of wiring can be absolutely spider silk.